about combining function transformations. So before you actually get to this lesson, you have to have an understanding of all the different transformations, but let's just assume that you haven't gone through those. We'll do a quick review here. So let's go ahead and talk about what we'll be doing. We're going to review transformations. So we'll look at translations, reflections, and dilations, and then we'll do some examples together. So let's go ahead and review translations. Translations simply mean that you're moving left and right, you're moving up and down. So here's the general form of and there are two types of translations. You have the horizontal translation, you also have the vertical translation. So if you had to move this, if you had to move left or right, you're going to have your movement inside of your parenthesis right here. And being horizontal, it always tends to act the way in the opposite of what you think. So if there's a negative a over here, you're going to move to the right. If there's a positive a, you're going to move to the left. But if you have the translation outside of your f of x altogether, it's going to behave as expected. So plus a means you move upward a unit, and that minus a would mean that you move downward a unit. Let's talk about reflections. Reflections are mirror images of a given function, and we have a few things to note here. I'm just going to draw these two axes here. If I have a point here and a point here, this is considered, because if you look at it, the reflection is an up-down reflection. So this is what we call a vertical reflection. And you can see here that what separates them is the x-axis. So this is your x-axis reflection. Now, if we had, let me use a different color here so we can show it. So if we had something like this right here, you can see here that it's a left-right reflection, and your y-axis is the thing that separates the two of them. So this is considered a horizontal reflection or a y-axis reflection. So let's keep going and talk about dilations. Dilations are compressions and stretches of functions. Horizontal dilations, they always behave in the opposite of what you think. So if the factor of dilation is a fraction in here, you have a stretch. If the factor of dilation is a whole number, you have a compression. It behaves exactly opposite when you're talking about a vertical dilation. With a vertical dilation, when you have a factor of dilation that is greater than 1, you have a stretch. And if you have a factor that is less than 1, just remember you can't really have a negative dilation here. If you have a negative, it means that there's going to be a reflection first. So if you have less than 1, you're going to have a vertical compression. And the factor is always going to be here because a is less than 1, so the factor is a. So let's go ahead and describe these transformations. Let's look at a few things that are happening. Here we have a translation and we have a translation. So here we have a horizontal translation, we have a vertical translation. So what is happening here is we have f of x, let's use this, the function translates, and here we have minus 3, so that means it's going to go right 3 units. And this is vertical, up 7 units. Let's look at the next one. Okay. This is a very interesting translation happening here. So we have here first of all, the function is going, so you have so here you have a vertical stretch. Here you have a horizontal, over here you have a horizontal compression. Then you have a horizontal translation, and then you have a vertical translation. So let's go ahead and see how we're going to go about this. So f of x is our function, is going to go through we call it a vertical stretch of 3. Let's call it vertical stretch factor 3. I think that's a better way to write it. Vertical stretch factor 3. Then we're going to have a horizontal compression. The factor there is 1/2. Then we have a horizontal translation, and we're going left 8 units. And then we have a vertical translation up 4 units. Let's do one more. So here we have a reflection. So this is going to be a vertical reflection. We have a vertical compression. We have a horizontal translation and a vertical translation. So we have f of x goes through a vertical reflection, or we can call this a x-axis reflection. Then we're going to go through a vertical compression, and factor is 1/2. Then we have a horizontal translation, left 2 units. And we finally have a vertical translation up 5 units. So now that we have been able to describe, we'll go ahead and get the description and then come up with the function. So what function is the result of the following transformation of y equal to f of x? So we go left 2 units, so that's going to be, so what I'm going to do, I'm just going to try to see how we can come up with the function notation for the transformation. Left 2 units, so that's going to be x plus 2. Down 5 units, so we're going to have x plus 2 minus 5. Reflect over the x-axis is going to be negative x plus 2 plus 5. So we're going to have f of x transformed to negative, so that is our x-axis reflection, negative f of, and then we have left 2 units, x plus 2, and then down 5 units. That's our function. And let's do one more example here. What function is the result of the following transformation of y equal to f of x? Reflect over the y-axis, so it's going to be negative x. Translate right 3 units, so negative x minus 3. Translate up 5 units, negative x minus 3, and then we go up 5 units. And you're going to vertically stretch that 4 units. Vertically stretch that 4 units, and that's going to be 4 over here. So let's go ahead and deal with our transformation here. So we have a reflection over the y-axis, so it's negative f of x, and we're going to translate right 3 units, so it's going to be x minus 3. Translate up 5 units and vertically stretch 4 units. So that is going to be the function representation of this described transformation. So you can see that once you understand how all these different transformations work, it's very easy to put them together into a combined transformation.